Here is an AP Chemistry free response question that deals with both energy, see these units here, as well as rates, also known as kinetics, if you see these units here. And let's go ahead and read this problem and solve it. The rate expression for the reaction above, where nitrogen monoxide reacts with oxygen to make NO2, and we have a rate expression. You don't normally see this modern day anymore, since this looks like some sort of calculus problem, but it literally says that the change in concentration of oxygen over time is equal to some rate constant times the concentration of NO squared times the concentration of oxygen. That means it's very sensitive to NO, not so much to oxygen. It's second order with respect to NO. First order with respect to oxygen, fine. We also have a whole bunch of thermochemical data, free energy, enthalpy, entropy, and free energy. Wow. And now here's the question. For the reaction above, find the rate constant at 25 degrees. The rate constant, K, we want that. If the initial rate is defined by the equation above is 28 moles per liter per second, that's our rate. When the concentration of nitrogen oxide, that's this, is 0.2 molar, and oxygen is 0.1 molar. So we have the rate, we have the concentrations, we have everything but K. That shouldn't be too bad. We'll just find out what K is. And finally, what the equilibrium constant, that's K, is, that's a different KEQ for the reaction at 25 degrees. Well, 2 points. One, this is AP trying to just intimidate you with the overwhelming amounts of data, complicated looking stuff, complicated sounding question, but really this is a direct plug-in into this right here. They give you everything except K. And here, equilibrium constant K, well, I know it's equal to the negative delta G equals negative RT natural log of K, and that should do it. So all I need is this stuff, products minus reactants. That's a gas. They should have a G there. But why did they give me S and why did they give me delta H? I think because they're being evil and putting in data you don't need. But maybe that's just me. Let's see how we did. Okay, they rearranged. Rate equals K times that, so K equals rate over that. It's just direct plug-in. They're not including their units, which is unfortunate. But I guess this is molar per second, and that's divided by molar third. So we'll get molar to the minus 2 to the per second. So molar minus 2 liter squared over seconds to the minus 1, right? Yeah, fine. And for the free energy change, we're just going to do products minus reactants, and there it is there. Don't forget the coefficients. And we get a delta G for this reaction. Plug it into K equals e to the negative delta G divided by RT. And there's your numbers. Hey, that is a unique form of R. This is the old form they used to use when they were dealing with calories, which we have here. They use 1.987 when you're dealing with calories, so that's a handy number to use when you're dealing with equilibrium constants, and we get a very favorable equilibrium constant. This is free response question AP Chemistry that deals with energy from 1975, letter B.